AI can now generate images, write essays, and hold conversations. But how? What makes these systems so powerful? The answer is often the same: neural networks. Inspired by the brain, these networks learn to make predictions from data, and they're behind much of today's AI revolution. In this video, I'll break down what a neural network is, how it makes decisions, and how it learns, step by step. Hi, I'm Oliver, a computer science student specializing in AI and machine learning. I've been exploring this field since middle school, and today I want to help you understand one of its most powerful tools: neural networks. So, what is a neural network? To tell you what a neural network is, I'll first zoom in on one fundamental concept, which is a perceptron. So a perceptron is actually inspired by neurons which are in the brain. So the mechanism which a human uses to think, where it's the connections in the brain send signals to each other, is actually what a perceptron is based on. So we have a set of inputs, which are here x1, x2, all the way to some xn, which are then being weighed by some w in a weighted sum with a bias, and the output of this sum then gets put through this function, and the output of this function will then be the output of the entire neuron. So this might be a bit much information at once. I'll note here which each of these terms are. So the bias here is this b. Essentially, it's always the same, irrelevant of what the input is. So no matter what part of the data you look at, the bias will always be b. So this is a part of the sum that's always there. These w's are the weights, and they decide how much of an effect a certain input has. So for example, if this w1 is 0, this would be multiplied with x1, and 0 times x1 will just be 0. So this input 1 then cannot have an effect in this neuron. And there is a weight for every single input. And the inputs, they are essentially what we put into the function and what is being decided upon. This could, for example, be the x and y coordinates, or longitude and latitude. That, for example, if you want to predict based on the longitude and latitude how high that place is above sea level. This would just be one example application. But so this component here that builds the sum will have the weighted sum plus the bias, and the output of this goes into a function that is called nonlinear. It's not very important right now what this nonlinearity does, especially because it's a bit more complicated, but essentially it adds a component which this sum here cannot. So it's able to represent things that a sum by itself is not. And the output of this is then Ry. When you write this out, this might become a bit more clear. So here we see this entire structure as a singular computation. So here it would be this sum here. This is why we have a sigma. And then this weighted sum. So our wi is multiplied by our xi. And then we do this summation over all i's from 1 to n. And then our bias term, as mentioned before, is not dependent on any input, so it is always added in the end. And then finally, our result here is passed to this function phi. And this function phi then gives us our prediction y hat. Now, we've seen what one perceptron does, and you can consider this the decision maker. So based on some inputs, it decides what the output is. Then to make this a bit more interesting, we can combine several neurons together. The human brain does not have just one neuron which decides everything, but a combination of them. So they are connected to each other. So the outputs of some neurons can be the input of another neuron. And by connecting these, we get what is called a neural network. So here we have an example. This is called the multi-layer perceptron. This is actually one sort of neural network. And from the name, it becomes a bit clearer what we have here. So we have multiple layers of perceptrons, and it's also frequently called MLP. Now, one circle here represents one perceptron. So in this case, these circles here represent the inputs. So we only have this one incoming arrow. And so we can, for example, write that this is our x1, this is our x2, this is our x3. Here, each of these perceptrons, or each of these nodes rather, is connected with each of the next nodes. So these circles here. And this would then be equivalent to the perceptron. So here, this circle would be equal to this here. All these inputs here that we have, so these 3 lines, would then be each one of these x's. So x1, x2, x3. And then these outgoing nodes would then be this y hat. So here we don't have several outputs. So actually what it means when it goes to several other nodes is that each of these gets the y hat. So the y hat is just copied into each of these outputs. And so then in the end, we have another set of perceptrons. These would then output this y, each by themselves. And again, in each layer, or in most layers rather, we have this nonlinear function. It's common that, for example, here in the last layer, we would have either no activation function, which is what this is called, or we would have a special type of activation function, depending on what sort of task we're trying to solve. But this would be what you would frequently call a multi-layer perceptron or a neural network. Now, when we pass a set of inputs through this network and get some prediction out, the type of prediction, or rather what values we get here, are dependent on these weights. And these weights, we do not know which are optimal at the beginning. So they're usually initialized as something random, which is not 0. And the idea is that we start with a random number and get some output here. And then based on data which we've seen, we can say, oh, for this input, we expect some output y, but we got this y hat. So let's see, what is the difference? So y minus y hat. So what is the error that we've made with our prediction? And then based on this error, which is called the loss, we can calculate what we need to improve. Here, in this example, we have these data points x, and we got this line as our prediction. So if we put in this x, we get this y. If we put in this x, we get this y as our prediction. And now we see that this prediction does not pass through every single one of these x's. Now this means that we have some sort of error in here. And there are several different ways that you can determine this error, but one common way would be to check what the difference is here and then square it. So this would be our y hat, and this would be the actual y. And so we would do y minus y hat, and then square this. And we would sum up this error for each one of these points. And the sum of this would then be called the loss, commonly just written as L. And the lower our L is, the better our predictions are. If you would map our loss based on the weights W, which we have used to do the predictions, we would see that for certain W's, we would get higher loss than for other W's. And in machine learning and our neural networks, we want to find the W that gives us the best predictions. So the W that gives us the lowest L. And as I mentioned before, we usually start with a W that's random. So let's say we land here on this W. We see the loss is around this height, so it's better than, say, this W, but it's worse than, for example, this W. And now the trick is to find out how we can improve our W. And one way to do this, which is commonly done, and is called gradient descent, is by following the slope. So in this point, we can see that there's a slope that tells us, okay, if we move our W to the right, then our loss will go down. And then we would take a step to the right, in this case. We would go down and we would get a new loss. This would be around here. And then we would repeat this, get a different slope, go further down, and get here perhaps. And then going further and further down, the slope will get less steep. And at some point, we will reach a minimum where our slope is 0. In this case, we know we found our optimum W. But this is only true for this area here. Had we started here, we would have dropped down into this local optimum, which would not be the best option from all the W's, but only from this area here. And this is a tricky thing in machine learning, that we might enter these areas where we don't have the optimal model, which is this W, but we can also not find a direction where we can improve it in. But this is more advanced stuff, and I just wanted to give you a brief overview. So in the end, a neural network is a system of connected neurons that take in data, make predictions, and improve over time by learning from mistakes. With every input, it adjusts its internal weights to get better at the task, just like we do when we learn something new. And that's the core of how AI systems like ChatGPT or image generators actually work. If you enjoyed this video, you might also like my video on logic gates. They're the building blocks of every computer, and understanding them gives you a solid base for how all of this works under the hood. Drop a comment with what you want to learn next and subscribe so you don't miss it. Thanks for watching.